we've seen the graphs of sine and cosine. I want to show you how we can use those to generate the graphs for cosecant and secant. Now, since cosecant x is 1 over sine x, and secant x is 1 over cosine x, it's going to be useful to just look in general what happens when you take the graph of the reciprocal of a equation whose graph you already know. Even a graph as simple as y equals x, which is a line like that, if I take the graph of the reciprocal 1 over x, it looks very different. These graphs look very different, but they actually do have some things in common that aren't so obvious when you first look at them. Actually, I'll put them on the same grid. First thing to notice is that anytime the red graph is above the x-axis, so is the blue graph, because the reciprocal of a positive number is still positive. And anytime the blue is below the x-axis, anytime the red is below the x-axis, the blue is also below the x-axis, because the reciprocal of a negative is also negative. The place where the original graph is 0, the y-intercept, it's undefined on the blue, because 1 over 0 is not a defined number. But another thing to notice is that as the y values get larger on the red, the blue values get closer to 0 on the blue, because I don't know, if this is like 10, 10, let's say. This point would be 10, 1/10. So it gets closer to 0, and you actually end up with this asymptote, horizontal asymptote. On the other hand, let's say this point really close to the origin is 1/10, 1/10 on the red. On the blue, it's going to be 1/10, 10, because the reciprocal of 1/10 is 10, so it gets really high up. And that's why we have this other asymptote, this vertical line. And these things intersect at 2 points, and they actually intersect at the places where the y value is either 1 or -1, since 1 is its own reciprocal and -1 is its own reciprocal. So the graph of cosecant x, we can produce that by first creating the graph of sine x. Sine x looks like this. That's the first 360 degrees of it. But I could actually make 2 cycles of it here, because it goes on forever in both directions. Okay, so there's our graph of y equals sine x. Now, for y equals cosecant x, which is 1 over sine x, a couple of things to observe. One of them is any time that sine x has a x-intercept, so the y coordinate is 0, cosecant is going to be undefined. So I have all these vertical asymptotes. Also, anytime sine is 1, cosecant is also going to be 1. So this point here, all these high points are going to be on both graphs. And also when sine has when it has a y coordinate of -1, reciprocal is also -1. So those points are on there. Now let's look at this little region from here to here, from 90 to 180. As the y value gets closer and closer to 0, the reciprocal gets bigger and bigger, and that's why you get that happen. You get this asymptote, and it's going up towards it. From 0 to 90, the same thing happens, and you get like a parabola-looking thing, but it's not really a parabola, because parabola doesn't have asymptote. And because this is the same, there's just a copy in the next period, we have those 2 guys. Now down here, similar thing happens. From negative 90 to 0. Right before I get to 0, sine is very close to 0, so the reciprocal, but it's negative, so the reciprocal is going to be a big negative number, because 1 over a negative number close to 0 is going to be a large negative number. And we end up with these like almost like parabola-looking things, alternating. One is above and one is below. You could also see here that cosecant is always bigger than 1, or it goes from, its range is from 1 up to infinity. And we can see that it's undefined, it's 0 at multiples of 180. We can also do this for, if we draw a cosine curve. And here's another cycle of the cosine curve. So that's y equals cosine x. And if I compare that to y equals 1 over cosine x, which is the same thing as secant x, again we have these points. All the 1's reciprocal is still 1, and all the negative ones are also. Now cosine has x-intercepts at 90, 270, anything if you add 180 over and over. And just like with the cosecant graph, we're going to get these parabola things. I mean, a cosine curve is kind of like a sine curve that's been shifted. So a secant curve is going to be like cosecant graph that's been shifted. Okay, and that's what the graphs for secant, cosecant, and secant look like. And we've also looked at, just in general, what graphs are reciprocals, what properties they'll have, if I know what the properties of the original one are.